And second could be one reason is uh, second reason is when we read but we don't practice, we forget it. And third is like it keeps changing. So there are many other things. There are a number of things. Today I saw something interesting which I would like to share. Very minor things. You don't focus on them until unless you go and think about it for 10 times. We don't get into it. So anyway, let's come to this first question. The question was, if there are multiple devices in the call hop, so how many call legs will be formed in this case? So the SIP talks about peer-to-peer protocol. So let's say if the call is from phone to CM, CM to session manager to SBC, and then goes to the some interface in the PSTN cloud, which will be again a SBC from PSTN service provider. So in that case, between phone to CM, there will be one call leg. CM to session manager will be one call leg. SM to SBC will be third call leg, and SBC to PSTN will be the fourth call leg. So in total, there will be four call ID, four call legs. Okay, so that was one question, and I have shared this document. Maybe I can, if today we get some interesting question, I'll club them and then I can resend it. It should be there in the same chat. Or maybe you can speak with Shankar and then grab this. Okay. So as such, four colleague, so four components. Now let's move to the next question, which was if there are, let's say all these call IDs are different from each other, it will be a unique ID only for that session between those two peer. Then how do we find out, or how do we trace a call from end to end? So for that, either you got to capture the entire call leg, club it, and then apply filter with all the individual call legs, call ID uh, into your query. So let's say if you're using a sniffer or if you're using a third-party tool to filter out such calls, so all those four call ID has to be added into the filter. So we'll see that some of them today. The another best example is which sounds very quite interesting is either you can insert a P charging vector. So P charging vector is for normally it is used for billing purpose to see end-to-end calls so that if a person is making two calls or if there is a multiple hops, then in that case charging vector is used. But this can be utilized over here in this case to track multiple calls and consider as one. And P associated identifier is different. It is a secure. It's a header which is used for different purpose. This is the response I got from ChatGPT. So it is how it is mentioned over here. But P, it might be used. It could be used over here as well in this scenario. But the main purpose for PI header is different. Let's say if there are call center, there are hundreds of uh, ERI circuits or DIDs which we have taken, and using those numbers we are trying to make a call, outbound call, and we want to display a single name, let's say the company name or a single number so that user can call back. In that case, we use PAI header. So that's the purpose. But anyway, so this is one P charging header. So these two were most important question, and then there were few more which I'll discuss that today. So Shankar, if you're back and then if you're good, I think it's 8:10. Maybe we can start.
Yes, 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 Binod. Let's get started. Yeah.
Okay. So so we were here. These were actual all the queries. I have answered for two of them, which were most interesting, and I think most will be here. And we'll see rest again. There are a few more. And I think we covered this one. There are six primary primary methods for request. So 1, 2, 3, 4, 5, 6. Yes, and you can see they are defined on the 3 to 6 one. Then there are additional requests which belong to different protocols, different RFCs. So for you can see here all the numbers are different. while primary 3261 has got only 6. Okay. So today my target is to go to the lab session. So I'll try to be fast onto this theory part and then jump onto the practical. So allow me, maybe we can stack all those questions if you'll have at the end, and then we'll try to make maximum use because lab might take some more time. So now this is the SIP response packet. As you know, there are two kind of responses, final and non-final. So, or you can say non-final is intermediary informations. So you can see all by color code here. We'll try to see demo of this. I'll not run through it. It is all written here, but we'll definitely see some demo. So let's see. And that was the compressed list. This is the detailed list for all these errors, and there will be few more definitely. So now this is the important slide which I would like to cover. Here, if you see SIP message, uh, I have tried to demonstrate how does a request packet looks like and how does a response packet looks like. So a request line which will have the first line which will have first thing is method, that is what we saw is invite, ACK. So those methods will be here. Then you'll have the second word which will be request URI, and then third term which you'll see here is SIP version. So you might see them under one line, a straight line. Let me put my pointers. You know, either you would see them in one line, or if you open it, you'll be able to see them all in different individual row as well, containing all those values. So after request line, it'll have message header which will have via, to, and from. These are six compulsory fields, compulsory headers, which will always be there. And then apart from that, there are a few other headers which may or may not be there, depending upon the capability and the scenario. So let's talk about one thing which I would like to share. This was one of the question in last session, that whether to, from, is this something which keeps changing? So the first answer to this question is no. Its value is always consistent throughout that peer-to-peer session. So, but what changes is their order. If you see here, onto the left side, I've tried to write it down here. The first will have source. So you'll have source and then destination. So, uh, okay. So, one second. There is a change in the sequence. I got to correct this. Allow me a minute. Maybe I can make that correction now. Okay, I'll have to go to the edit mode. Maybe I'll make the correction and share it. First, we'll have the with first we'll have the source. First, we'll have the destination where we want to send, and then you'll have from. So, okay, this we'll also see during the call. So via to, from. So yeah, this is the header. I'm so sorry. Via will have the path, but after that you'll have two where we are sending our request. So this you'll see in the header. Then that will be coming first, and then from source. Maybe I need to change this one. Okay, there is some inconsistency, but when we'll see the lab, we'll be able to figure out this one. And the via header, it is like hop by hop, every uh, every device will add its information. Like if you can see here, it's written as you should start it reading it from right to left, because the first message was added as origin, the requester, then it went to the proxy one, so it was added on top of it, and then it was P2, so which was added onto the let me bring the pointer. Okay, so if you see here, first is the so LIFO, last in, first out. So the first message will be the originator, then the proxy one, and then the proxy two. So on top, what you will see is proxy two. And if you see onto the reverse side, this list is copied as it is P2, P1, and origin. what it will do is when it is routing the packet reverse wise, it will follow the same path. First it will reach to P2, then P1, and then origin. Here it was origin, then P1, then P2. And here it is P2, P1, P1. So it is like LIFO, last in, first out. And if you come to the message body part, which is SDP, it will have media attributes like connection information, media information, then some media attributes. So there could be multiple of them. Okay. So we'll see this again. Let's see. This is one of the sample packet. How does the request response? It's the same thing. This is a small setup. We have an Asterisk PBX. We have phones like 2000, which is closest to this one. Then we have a 3000 series, which is also registered to this PBX. And then I'm running all the presentation and everything. And Wireshark will be running from our PC, which is the last PC on to the left. So let's go to this one. This is how our basic call should look like. Invite from Alice to Bob. That's an example. So for invite, you will see 100 trying 180 rigging 200 OK and then ACK. Then once this ACK is complete, we'll should be able to see a media transmission. Then a party if sends a buy request, it should be acknowledged by 200 OK, and 200 OK is a final response as we saw in the last slide. So we'll see an example before we talk about it much. So allow a minute. We'll say this. And in the lab, if you will have any query, we can talk about it again. So this is a server on which we have installed um, the Asterisk PBX. So let me quickly log in into it. I hope everybody is able to see this. First, let me verify if my Asterisk is running or not. Asterisk is a small sample PBX. Here we have configured another version of SIP called PJ SIP. Okay, and we can see here that my Asterisk service is running. So I should be able to connect into it. It should be able to route the phone. It should be able to register the phone. Okay. Then we have added few extensions. So we'll see through l- let's have a look at all the extensions which we have. So as we saw in the diagram, we have 2001, which is on this Linux PC. This Linux is a virtual machine. It is sitting on another Windows machine. So this is the another machine here, and here this is my let me see if I can clear this. Open dialog. Okay. So and this is the Windows machine which is hosting it. Here we have another phone which is like 3001. So this is the next hop. So these are two phones as of now. Let's say we are trying to register, and then we'll try to make a call from each other for making any scenario. Okay. So if I'll start here, let's say if I make a small test call and then see if my calls are going through or not. But before that, let's see the station extension. Okay. In order to connect to this asterisk, I'll do R is for connect. Okay, remote session, connecting it remotely, and V is for your verbose mode. We'll verify if there is any extensions registered to it. Pages. Okay, PJ-SIP show endpoints. Okay, it is actually PJ-SIP show endpoints, and you can see here I have got few phones registered, which is 2001 and 3001, and this is called binding. So wherein you have your extension number, then AOR, it's a URI, and then it should also have the port. So this port on this phone is being used for the communication. So you should be able to see this 4111776 and 35222. So we'll see this during our course. And if I see my all AORs, address of records, I can see there are few records. So I think we are good to start with. Let's make a small test call and then see. What I'll do is I'll keep this windows to minimum, and then we'll try to have another session which will show us the call wherein we'll enable the Wireshark capture. First, let's see which all interfaces we have here. Um, for that, the command is TCP dump minus D. So here I am using on interface this ENS33, which is up running and connected. So I'll make use of this. I'll make use of the same command. The command is simple, TCP dump minus I interface, which I'm going to monitor. So ENS33, and the file which I'm going to write is minus W, that's a parameter, and let's say call between 2001 to 3001, and I'll give the file name as pcap. Okay, so let's say my trace is on. Here I should be able to see the live status. If at all any call is happening, we should be able to see here coming up. And let me get connected to our phone. So this is one of the phone which is already registered. I'll start with dialing 3001. Okay, this should ring my extension. I'm not sure if you're able to hear this message. The ring. Uh, okay, so let me show this over my. If you can see here, I can see this call coming here. Incoming call on line number 1 from SIP URI, which is 2001, and its IP address. Okay, so let me answer this call. Okay, so my call is connected. Let's go back to the server, and you can see here, I'm able to see some call logs coming up here. It shows you a stack. So 2001 calling into 3001. Okay, and looks like it got hung up as well. Okay, let me go back to the Windows screen. And yeah, it got hung up. Maybe this got hung for a moment. What I'll quickly do is, my machine is little freezed. One moment, please. I'm connecting into my lab PC. Okay, so once it is connected, we'll go back to our Asterisk server, stop the Wireshark capture which we have enabled just now, and then we'll quickly analyze and verify whatever we read till here. Okay, so here we are. Now this is our Linux box. I'll stop this Wireshark capture. So this should have created a file. Okay. Uh, Actually, the file is over here. So I'll move it to another folder wherein I can capture it. Move, the file name was call. I have kept a folder which is shared into my other machine where we have Wireshark. So now I have moved the file from current directory to this SharePoint folder. Let me quickly share my this screen, the Wireshark capture, and let's load that file quickly. Okay, so the call which we made was call 2001 to 3001 PCAP. Let's open this file, and this file is loaded. It has got a lot of messages. Let's verify quickly if we have our SIP call into it or not. So yes, there are few SIP messages. So sounds good. In a quick glance, if you want to see, what we can do is go to telephony and then see if there is a call or not. This is another way of quickly verifying it. So it is there. And first we'll have a quick glance onto the call flow and then we'll go deep into it. So let's go to this one. We'll make a flow sequence. And if you're able to see, so here what we are doing is, as you can see through the SIP invite, unfortunately I cannot maximize it. Let me know onto the chat if this is not readable for you. In that case, I'll try to change it. So here, if you see, the first thing is invite was sent to from 2001 to, let me try to adjust. Okay, unfortunately, I cannot bring this down here, but I hope you can figure out this one. From 2001, we were trying to make a call to 3001. So first there was an invite, then 180 ringing it from the called party, 180 ringing 200 OK, and then in a response we got a ACK saying that okay, yes, please proceed with the call. And then after this call was acknowledged, then there was a media transmission which is not being shown here. And then after that there was a buy, then 200 OK. And then there are few cancel OK. This was because the call in between got stuck due to freeze of the machine or the software. So anyway, ignore that for now. If required, we'll have a lot of instances where we'll be able to capture it on another call. So what I'll do quickly here is if I want to see through this one, I can see that there are a lot of binding messages and all that. So for now, let's say we are focusing only on our call. So what I'll do is I'll catch one of the call which sounds to be related to our number. So let's say I'll ignore in I'll try to look for invite. Okay, so this invite is there. Now there are two methods. Either you can go and with this call ID you apply as filter, and then you can see all the calls, all the signaling message which happened over here. So in this we can see the same message what we saw through the call flow through the ladder diagram. So we can see here 3000. What this is the request URI request line wherein it has got invite as the first method, what we saw in our PPT. Then the second part was your SIP URI, and then last one was the protocol, uh, SIP protocol version. So which is not being shown here in this one, but if you come down here, let me first close all these packet headers, and then we should be able to see the down below. So if you see here, if you remember in the previous day slides, we read about it. Every packet is encapsulating another packet. So as you go from down to up, from bottom to up, your packets are getting encapsulated. So first, the lowest will be frame, then Ethernet. Okay, then IP third layer. IP will also have your DHCP values if it is configured. Uh, then UDP, the transport layer, and inside UDP you will have the last packet, which is your SIP header, which is an application layer packet, which makes sense here. And in this SIP, there are three things which will be there. First one will be the request line, what we saw a moment back in our PPT, then a message header, and then the message body. Message body is optional because sometimes SDP will not be there in an invite. Here SDP is there in an invite means it is an early offer. So we are offering the calling party is offering the SDP parameters in advance. So that's why we call it early offer. Otherwise, in the other scenario, it will be wherein the uh, offer from the calling party will be sent only after ACK, after it hears back from the called party. That is mostly after 200 OK, and once you'll see the SIP invite, then after that you'll see SDP information going from called party to the calling party. Okay, so let's go one by one. Whatever we read about request line. So if you remember, we just discussed in method, SIP URI, then there are many other parameters. We just saw what is key and what is most viable. And then the last item was version, SIP version 2. Method was invite, request URI. If you go drill down again, you can go still deep into it, and then you can see what is the part, what is the user part, what is the host part, which is you can call as well as domain part. Like this is the user ID and this is the domain ID. Then which port has been identified? If you remember on the SIP traces, we could see this in our Linux terminal when we were looking at AOR records. This was the port which was identified for communication. So let me close this so as to keep it simple, and then we'll go to message header. Now message header will have again via from to, then contact CSEC. These are five important fields, and then there are many other fields which will be required or may not be there, but there are many things. We cannot go everything into this one, but uh, I I hope at least you can see that important parameters are covered here. So via header, the originator who initiates the request, that information will also be added here. So who initiated the request, that was uh, so that is added over here. So you should be able to see this ID. Uh, this is the 1.4 is the IP of the our Asterisk server. It is working listening on port 5060, and then you might identify this one branch ID, which start with your magic cookie. That's what it is called as. It always starts with Z9H GK4B till K BK. It is a magic cookie, and then after that there will be a random number which will be maintained throughout the transaction. Okay. Now coming off from. So who initiated that request? So from will have, so 2001 was calling to 3001. So from and to. And if you drill down deep into it, then you can see those fields with individual parameter. And if you close this, you should be able to see the gist of it in one line. So from to, okay. So, and this is the call ID which we applied as a filter. You can see here C6 ending with C6. Then CSEC for invite, and then a random number which was picked up for this call. And minimum session expire is for this call. What is the for this phone? What is the minimum session which expiry has been defined? So for this session. Yeah. Now there are many other things which I may not able to recollect. So I'll skip some of those things because there are a number of parameters. I'll quickly talk about few which I do recollect well. So it also have a header called allow, which shows which all SIP methods are allowed to communicate over here. Now, when user A or user agent A is sending this message, the other side party will also revert in a response. They will also have their own allow list. So if both these things match, then only they'll be able to work on, they'll be able to use that method. If this thing, let's say UA, user agent 1 is sending out a publish message, and user agent B does not support this publish, then they can never go into a negotiation for, or they cannot do a transaction related to a method related to publish. So I hope this would be very easy to understand. Then 100 REL is if you need 100% reliability, then in that case they support PRAC. Okay, and uh, so user agent is in this case they're talking about the PBX. SDP is the application, and the if it says content length is 235, that means it has some SDP body, which we saw just now. There is, we can see here, over here as well, it has some SDP information. So let's see what is the SDP information. So in SDP, if you remember, we had a creator, the one who created the session, or you can call it originator. Then you had some C header, as you saw on the slide, then some time parameters, then media attributes. So media talks about um, the port which will be utilized. I believe it should be the port 15864, and then uh, th- it says RTP profile, audio video profile with, these are the codec list. So 0101 and all that. Now, what is 0101 and all that? That will be again further defined over here in this down this list below. So you can see a definition of 0, it is PCMU, 101 is your telephonic event, and then there are few other parameters. Then another parameter for you is send receive. So send receive means it is two-way communication. In some of the instances, you would see that this will be changed to send only or receive only, usually when we are putting the call on hold. So that's a small explanation of this one. And for this request, let's say what is the response, we can see this. If you remember, there was a header, the request line, we'll go from the start. It started with your version, then response code, and then a reason or explanation of that code. So it is version 180 ringing, and then there is a header. So header will again have the same thing. If you see here, from value is 2001. If you look at this one, here also the from value is 2001. Then to value is 3001 in request, and if you go to response, to should also be 3001. 2 is also 3001. So from and value never changes. What changes is the order. So it will always be in a format like via, then let me go to this way, via, then from where it is sent, and so source, and then destination. So via, source, and destination. So this is how it should be. And here in the response, you'll see via, source. Now 2 has become source for them. Okay, 3001, it has become a source, and from is now destination. So via, source, and destination. This will always be there. And then you will have the CSEC for invite. So since this is for invite, if you see here, this also helps in correlating the call legs. So this is, if you see at the random, first of all, this is for method invite, and the random ID which is given is 4200. So if how do we correlate whether 180 belongs to this same request or not? So it will have the same method and the same uh, code. Okay, if there are multiple invites, let's say in one call, then how to interpret? So this code will be unique, and that will help you correlate all this information. Now, I think I have spoken enough about it. In case if anybody has a query, please feel free to interrupt, or ask me any query if you have.
Why is that
Uh,
content length 0?
Content length 0, yes, we'll see that. And I also wanted to verify this, where to send. So VI is where to send, and then source and destination. I think, yeah, this sequence is right. Okay. Yes, ma'am. Let me go back to your query. Content length is 0, yes, in this case. And you know why? Could you answer yourself?
I
Okay.
think that the
Uh-huh.
session has not.
No,
Sorry, I
madam.
can't remember actually. Yeah,
No
right.
worries. No
Okay.
worries. Maybe I might not would not have explained properly, but let me just explain this. Content length is 0 because it does not contain. Do you see any SDP information here in this second packet? No, right?
Oh yeah, no, correct.
So since there is no SDP, it says that okay, further there is no message. But if there is SDP, it will say that okay, yes, there are few messages. Please go and read
Messages.
them as well. It's like a
Yeah.
PTO in your book notebook. You write PTO. Otherwise, examiner will miss that paper. Uh, okay, you can see here as well. Here it is 236. In other SIP, you will see that it is 0 because wherever there is SDP is missing, the content length will be 0.
Okay. Okay. Thank you.
Okay,
but
welcome.
you
Mhm.
know, why in this call flow? Why is that there is a cancel message? Because there's already
Okay,
why.
this is not a healthy message. Actually, the phone, soft phone, got hung. Actually, let me open a better one.
That's fine.
This,
So you can explain the scenario. Why there's a cancel and why there's a 481.
yeah, yeah. I'll come to that scenario wherein we have few scenarios which are covered here, and we'll talk about it. I'll try to recreate the scenario of cancel. Will that be good enough? It will have we'll talk about few of these scenarios like 401, then 404. Then 486, 487. 487 comes under your cancel request. So we'll see in detail and we'll try to recreate the scenario and then 603 decline. So there are a few things which you can see. I'm not able to cover up for proxy because I had to build proxy server for that. Mm. So shall I proceed, Shankar?
Yeah, yeah. Please go ahead. Yeah.
Okay, we'll come back to this one. Okay, so this is what we have seen already. Basic call flow, and I think we saw this. So this is what we already saw. Okay. So I'm not going into this one because we have already seen this already. Now let's come on to the media setup. So on the same call, we might like to go, I'll rather pick up another one which will show you how the media negotiation does happen. So first, let's go through the theory in a quick glance. So USC sends an invite, so it is sending some HTTP parameter. It says, "I'm sending all these codecs. Do you support which all codecs do you support? Please share your list. Then we'll agree upon one. And once they agree, they'll send out an ACK. So the UAC, the initiator, will send out an ACK who sent the invite. So let's see this as well very quickly. File open and I have my file in a different folder, SIP captures, and I should have a good call, success call, let's say. I'm just taking, to save time. Anyway, we know how to see the capture, how to take captures uh, for our instance. So here, this is another SIP trace. And if you see here, one thing which I would like to quickly mention, you saw when I did not put any filter, it had got lot of messages into it. If you see down below into the screen, it has got 1092 packets, okay, which is 100%. As soon as I apply filter of SIP, it turns down to 1.5%. So out of this 1.5% is my signaling. Out of 1092, just 16 packets are signaling. So you can imagine around 1080 packets are roughly 1080 packets are some other messages. Now, what are those messages? We can see that as well. I think if I should be able to see this. filter. Okay. If you see here, now this contains the invite of the same call. Now this has become little complicated. Okay, it has captured all those frames and all that automatically. But you can see there are multiple RTP messages. Okay. So if you see here, so this contains your invite message or signaling, then your multimedia or RTP session which is transacted. And down below, I should scroll down fast. Down below, if I see, there again uh, buy 200 OK and all that. Okay. So we'll see this. What I'm trying to show in this by this is 98.3%. Okay, let me do one thing. In a straightforward manner, out of 1092, 1073 is all related to your this call itself. 1073 is only this call. Rest 20 messages, 20 packets would be related to your ICMP and DSCP, flooding and all that. So our voice packets is 1073. Out of 1073, 16 packets were only related to signaling. Rest 1060 packets are related to RTP. We can also do a quick thing is where we kept SIP as a filter, where we could see only SIP messages. We can also write RTP as a filter command, and you should be able to see only the RTP messages. So if you see here, there is no SIP invite. It is all RTP. And few ICMP is there. Okay, I don't know what is this, but anyway, but if you see here, 1057, 96.8% of the messages is RTP. So that's why what we say, what we are trying to say is this answers another question is whenever we in the real time network in you'll have to give a highest priority to RTP messages. And there is, in case if a packet is missed or a sequence is lost at the transport layer, then it's better to ignore. And that is the reason why we should go for UDP. Because even if one of these packet out of these 1,000 packets, let's say 10 packets are lost, it's better to discard it. But signaling messages are very less. So sometimes people or in the design they use TCP for signaling and UDP for your audio path or RTP media. Okay, by the way, I came here for I think we wanted to see media negotiation. So let me go back to this and we'll go for a quick glance. This time I'll use another method of going to the call filter. Apply SIP, and in this case, we'll take this SIP as a call ID. This I'll use as a copy value, and I'll change my filter to SIP dot call hyphen ID is equal to. This is the syntax how you should write. I hope you are able to see this onto the search window. So let's go to the media negotiation part. Do you want me to increase the size of the screen so that you can view it clearly? Let me do that. Okay, I hope you are able to see it now in slightly bigger font. Okay, so here if we have invite, so we can what we are trying to show up here is when we are sending this message from invite, so user UA1 or user agent A is sending to user agent B. It is sending a HTTP information. So where it will be? It will be not in the header. It's a media part, codec part. So we can see here in this message body in the HTTP information, it is transmitting the list of audio which it supports 106, 9, 98, 101, and 183. This okay, yeah, 106 is Opus, which is the new protocol, uh, mostly widely in Teams and all, you'll see it Opus. Why? Because it's codec, it's encapsulation, or it has a adaptive codec. It can reduce and increase and change. Okay. Anyway, so the first is SDP when it is sent from user agent A to user agent B. So we saw this. Ignore this 401. We'll talk about it in a while. Let's focus on to this one. It sent a reinvite again. Mm, so here it has the same codec 106998101083. When the second party says okay for a invite, there is 100 trying, 180 ringing, 200 okay, and then when it sent 200 okay, it sent out an SDP information. So this is from user agent B. You can see the IP address has changed. Initially it was from 1, now it is from 133. Now this time it is sending only two codec list, which is 0 and 101. So when user agent say that okay, I'm sending you 6 parameters, uh, all these codec sets. User agent B says that no, I only support this two. So they said finally, okay, let's go back and set up a call onto this one. And if you look at those RTP, you should be able to see that later on. They will agree and they'll set upon. They'll agree into one of this codec, which you could see through the. I believe through RTP we should be able to see that which codec they are using. Okay, RTP. There should be a codec information. Main. Okay, fine. No worries. I'm not able to see this clearly over here, but it agrees upon one. Okay. Any query in this in codec negotiation? In fact, let me try to put a filter like this. Prepare filter close. Okay, 100 trying 200. Okay. Okay, so SDP information frame codec SDP. Let's see. There will be I 011. I doubt if it is zero. One of this field is zero as used as a codec. Okay. Uh, Maybe one of these would be used as a codec, which could be okay, not clearly visible over here, but okay. But anyway, onto the RTP, you can see it is G711 PCMU. And what is this PCMU? This is what they have agreed upon. And if you see all this communication is happening on G711 MU, why? It should be there on both the side of the packet. So other way of looking at it is 0. If you look at this 0, if I'll expand this, you can see here it is PCMU. So media format is 0, MIME PCMU, and sample rate is 8000. And this will always be there in your invite. Otherwise, it would not have been there in the picture. Okay. So now what we saw in this codec negotiation, let's come back to the slide and then go through it. So here it says RFC 4566 is offer and answer. So what they offered is like this list. While reverting, it had a smaller list, and they finally agreed upon one, and then they proceeded with one of the communication. So this is one of the example, like 9981 is this is what we saw in our example, and the response you had 0 and 101, followed by this. The our message was communicated only into one of this. Now this is the time when we'll talk about it. So last time it was a good call, what we spoke up until here. Now let's take as example scenario of cancel or some field called message. So here we'll talk about few of the scenario wherein a user sends a cancel message, then how does it look like? Or in what all scenarios you can see cancel. So I've taken two scenarios here. I'll talk about it. But before that, let's go and discuss through this slide quickly. So this is all a failed scenario. Alice is calling to the Bob in this case, and proxy servers sometimes they are configured to revert back with 403 forbidden. When it says this call is not authenticated, they should not call. So in this case, proxy is configured. Uh, I don't have that scenario right now to build because that need a special configuration on proxy, which will forbid unauthenticated call. So then it sends, okay, fine. 403 white is because the phone is not registered. So it says fine. Let me now the phone has got registered at your end. So now let me register this phone, and then once the registration is completed, after that again it sends a new invite saying that okay, and let me try once again onto this number. So it says fine, I'm giving a call. So proxy takes this message, relays it to the endpoint device. So it is invite reached here. In a response, it gave 180 ringing. It transmitted over here. But before the call could be established, the user said, okay, the originator said, okay, I don't want, maybe the user is still not available. I shouldn't disturb. I should cancel the call. So in this case, UA1 sent out a cancel, which reached to the party, and it reverted with, so once a cancel is received, it sent, the receiver sent out a 487 message where it says 487 request terminated. And for this kind of 487, whenever it is terminated, or I'll say in this way, uh, whenever you see, let me bring out my laser, whenever you see a cancel request, cancel invite, or say cancel method, it will result in two response which is compulsory. One is 487, wherein it says request is terminated because you ask for cancellation, and it will also send out 200 for this cancel message. Uh, okay. Now this 487 it was because now this because 487 was sent out. For this there will be a respective ACK. So please note it that this ACK is for 487 request terminate message, and this 200 OK is for cancel. So they two are separate message. So what happens is, to answer it, if a cancel message is sent, there are two messages which has to immediately flow. One is 487 and then 200 OK for this respective cancel. Now this 200 OK is not relevant to your invite 200 OK, and we'll see this through our branch ID when we'll go through the example. And in case if there is a number which is not registered, then in that case we'll see 404 not found. So let's go to the scenario, and just do let me know if you want to trace this call, uh, see the demo, or you I have already captured it and then you want to go through it. I think it will be interesting if you go through a demo. Does it make sense? Okay. Only thing, it will take a lot of time, but let me do that quickly. It will be a little interesting. Okay, so first thing is, what I'm going to do is, we have extension 2001 here. From this, I'm going to make a call to 3001, and what we'll do is, we'll not answer it from 3001. So after some period of time, some period of wait time, this call will get cancelled. So in that case, 2001 will say, okay, fine. Anyway, the call is not getting answered at the other end. Let's not retry. Let me cancel the request. So we'll try to recreate that scenario. This is one possibility. Second possibility could be the 3001, which is on the other side, that is not registered. So since it is not registered, the call will not be connected. So that is the third scenario. And fourth scenario, which we'll try to see, is we send out a call and immediately we send out a cancel request as well. And we'll see how does the cancel is acknowledged. So let's take that as an example. Let me change the folder first. Here we'll do capture. Which file to write. So let's say my file would be name would be 2001 calling to 3001, no answer dot p cap. Okay, so this is a scenario wherein will not answer this call from 3001. So let's take this quickly. I'll not use the history, rather I'll make a call from here first. 3001. Okay, let me clear this log as well for the PC. This is a real-time log. So if I make a call from here, we can see on the PBX it is showing a real-time call. Why? Because we when connecting into the session we gave minus VVV and I can hear the ring. Let's go back to our Windows screen and see if at all this phone is ringing. Okay, so incoming call came up and it got hung. So this phone was actually ringing before I could switch my screen. Okay, so there is a call which was missed. So that's what we see in the message. Okay, so let me quickly stop the capture. Okay, my session is terminated. Quickly, let me connect back. Okay, so I'm back to my machine. Quickly, what we'll do is we'll stop our PCAP, Wireshark capture, Control C. Okay, now quickly load this file here. So we'll have to go to our my actual desktop. Let me close this file. Go back to the file which we just log file which we created. And in this case, I kept it under U12 share, which is a shared folder. And I think this is the file 2001 calling to 3001, wherein 3001 will not answer it. Let me open this quickly. And we can see there are 619 packets into this. We'll see the SIP message. Okay, yes, there are few messages. And we'll catch hold of invite message and we'll just filter with are this call. So to save time, I'll go this prepare filter and close. So we can see here invite it sent out as HTTP information. Let me close all this. So you can see the SIP invite was sent. 180 was ringing and so user agent 1 sent out an invite. It was ringing on the it got a 180 ringing from user agent B, which is 2 to 4. Then it after some time the request when it got expired, then user agent A itself sent out a cancel request, which you can see here. Now, last time, Shankar, to answer your question, I see that whenever I disconnect a call in this VMware session, my application is getting hung. So there is some issue with the conflict in the software, soft phone, and the VMware, maybe because of the interface, which is configured as NAT or bridge network. So that is looks like there is some conflict on that. So anyway, because it is so it will send out a cancel message. And what we saw just now onto the slide that for every cancel there will be a request which will be initiated from the user agent B side saying 487. And for this 487 there will be a obviously if a request is there for that there will be an ACK. And the second message which we spoke about is there will be a cancel message, and for that there will be 200 OK. Okay, every time there is some or the other difference. Here it is call transaction does not exist. For this ACK, actually here some of the information is still missing. Uh, This is different. But anyway, whatever we have captured, let's go through this very quickly. So we will see here in the first question which comes up is which part of the message we should look into this? Should we go to message body SDP or should we look for header? So in this case, we are not interested in looking at message body SDP. Why? Because call was never ever established. We are only interested in looking for signaling. What happened in signaling? And all signaling message, the first thing which we should look at is request URI and all the header information. So let's go to header. In invite, we can see here that a request was initiated at uh, first of all, we'll see. Okay, I wanted to show you the call ID. So call ID should be consistent in all this case. Obviously, we can quickly run through it. So keeping on this one field, we can see C162. So if I switch, it will always be, you can see here, it will keep highlighting this. So C162. So all the time this my call ID is consistent, fine. Now what happens is on to the call sequence, CSEC. If you see here, initially the invite was sent, and after invite, 180 ringing, which is for invite, but the code has changed because this is in respect to the invite. Okay. Now cancel. Cancel was initiated by user agent A. So now this number would match to the invite. Why? Because it says that, okay, I'm sending out a cancel message, starting a new sequence, but this number has to match. This is in relation to whatever we sent out an invite sometime back. Now this number, let's go and check whether it is same or not. So we go to invite and you can see here CSEC has got the same number. So within call ID, now you have so many things to identify further. Whether this cancel is relevant to which one, this call, and for what sequence, for what request. So using this number, it came to a logic that, okay, I have to go and look for this invite. So this cancel is for this invite message. Okay. So we said that whenever, so user agent A sent out a cancel message, in response, you get a 487 request, which was initiated, uh, okay, which was initiated from user agent B side. Okay. So user agent B, we'll see this. User agent B for us is 3001. So you can see here with the same logic via source, then destination. So source is 3001 is sending to 2001 saying that, okay, please cancel the invite. Now this invite is this 487 message is for the invite which you sent out. Okay, the invite which you sent out sometime back. Now that invite is matched to this invite request and this request number as well. So 23200 is also in the invite. You can see the number matches. Okay, so after 487 is sent out, it will also send another message. Okay, in this case, it is missing. I'll rather open another file. Okay. Uh, Now this, because this request for this, now 487 is a request actually here. Request being terminated. No, this is a response 487 request terminated. So for this 487, there will be an ACK. Okay, 487 for this, there is an ACK. You can see it is coming from the reverse side. So reverse side, it says that, okay, this is for 2300 and this is a response for uh, this is a response for your 487. There will be a message for this as well. Okay. 23200 is the invite method. So for the same method invite, I am sending out you this ACK that, okay, I have acknowledged. Let me do this. For some reason, this call was some part of the capture was missed. I should have another file wherein it says no answer. Bear with me for a moment, and I'm opening that file. Okay, this is some time back which I captured this, and I should have an no answer for this as well here. Mm, mm, mm. Okay, no, I think it was in that itself. Answer pickup. Yeah, I think this is one another scenario which I captured some time back, wherein 2001 was calling to this, and I'll apply the same SIP filter 487. Okay, so 487 180 ringing, invite was sent, then ACK was cancel was sent out from the originator, and in a response 487 was sent and 200 OK cancel. So this is what I was trying to convey. Once a cancel message is received, it will give the receiver party, which you can see here. 1.2 is a receiver party, user agent B. It will do two things. One is it will send out a cancel, and it will also send out a 487 request terminated. So now if it is sending out 200 OK, but this 200 OK, we should notice that it is not for invite or anything else. It is for cancel, and that's why this tool, Wireshark tool, has identified that okay, it is relevant to this cancel. And that's how it is showing it. And we can also read this very clearly. Why? Because in cancel, if you go to see cancel message, it is 31599 and cancel. So this is the request number, and your method is cancel. So CSIC number is 31599. Let's go and see this cancel message. You can see it is copied exactly 31598 and from the same method. Okay. Now this number will definitely be should be different from the invite if it is not copied from invite. We'll see this. Okay, so this is invite has been copied, but 3159. So it is showing that okay, it is here it has been copied, saying that okay, it is being used from the same number for the same call. Now, so for this cancel, there is a response. It has been answered. So request response has been completed. Now there is 487. Now this 487 will cancel. Cancel has been acknowledged by 200 OK, but 487 has not been this invite saying that okay, I'm not going to make another call. That has to be answered. So that is through 487 saying that okay, you don't please call further. Request is being terminated. So this call ID will match with invite. So which you can see 3159, and this time it has to match with invite and the code. And since there is a 487 message, uh, it has to be acknowledged. So there will be an acknowledge for this 487. So you can see here it is ACK for this 31599 again saying that okay, now this invite will not be processed any further, and we are closing it by ACK. Okay, so any question till this point? Maybe another thing which I would also like to show up is in this case, we called from one side to the other, and then call kept ringing for some duration. What is the duration? That is some session timeout. For that also there is a timer. And where do we define that timer? That timer we'd be defining where the phone call routings are happening. So here you can see very clearly it is 13 plus 48. So 30 plus, so there is a difference of 30 seconds. Let's see and open another previous file. There also we should see a same kind of correlance. Open. And last time our packet was we are calling from, I believe 9 p.m. This should be the latest one. If I go to SIP, here if you see our SIP message invite. So 23 is the first invite which was sent, and at 53 it sent out a cancel message. So there is exactly 30-second difference. So it might prompt you that why there is always a 30-second difference. It is because we have defined onto our PBX that for a phone, this has to be the maximum time. I think we are going beyond our time. Maybe I could show that parameter as well. But okay, this is how about the cancel. You'll see a similar kind of message if okay, I have written down here in this PPT that there will be two messages. One is 487 and 200. Okay, okay, for this message, transaction and dialogue. Okay, quickly I'll take another 5 minutes and then I'll throw some example because it takes a lot of time to go through each traces and then show you. I'll talk about call, hold, and resume. So if a call is been put on hold, you'll see that in the request message there will be a re-invite which will be sent out wherein it will change the parameter with saying A is equal to inactive. Okay, so it says that okay, my call I'm not going to receive any traffic onto this. Turning off this media attributes. In at this case, your call, the stream from the user agent B will not be transmitted to the originator side or the other party. So media path will become inactive. Once again, a re-invite is sent. If you can see here, call sequence 2, and then after this, same number was incremented to 3 for the re-invite. The same attribute was modified from inactive to send receive. Okay, and every other parameter will remain same. There is no change in any other parameter apart from just this media attribute. So this will define how the call goes on hold and how and when it comes back. Okay, and I'll quickly, yeah, always we have seen user registration. So once a user registers, it says 100 trying and then finally you'll see 200 OK. And once user agent server register receives the request, it will write into its location database. That what we saw in our AOR command output when we were running through it. And we'll see another capture which I would like to show. If you notice here, there will be whenever you'll see a Wireshark trace, you'll see a lot of binding messages. Why? Because if you see there is a pattern 25, 78. So there is always a there is a rebinding request every 53 second. Now why this is 53 second? Because we have kept a timer of 60 second in a phone, and you know that any renewal will happen. There is a rule for lease renewal. One is first timer, which is 50% of session expiry, which is 50%. That happens at the IP layer. I mean, for DSCP binding and all. But when it comes to the phone ID and its port and address record, it happens at the second timer, which is rebinding time. So first one is renewal time, second one is rebinding time. So rebinding time is the time when the phone re-registers with this registrar. So it happens at 87.5%. And you can see here 53, all this consistent value. So 53 of 60 is actually 88.5%, roughly near about that. So the differences could be because of millisecond differences. We are only counting upon seconds here. We are ignoring millisecond field. So you can see at every 87.5%, we can say that a rebinding request is coming up. We can see that onto the Wireshark trace. And another thing which I wanted to show you was an unintentional disconnect. How does it look like? So if you see unintentional disconnect, you'll see if a phone has got unregistered, let's say this scenario, if I'll talk about. So one phone, which there are two phones which wanted to have a communication, and this is my Asterisk PBX. So it sent out a request initially, and this phone was, let's say, disconnected. Okay, so it will wait for the 30-second timer. This call, the user agent A will keep trying for 30 seconds. Once the timer expires, then it will send out a error message saying that decline 603 decline, which we can see in the Wireshark trace 603. Okay, and if you see the real-time Wireshark trace, you should be able to see in this as well. The call being failing here, but you may not be able to see 603. Okay, it will be little bit different. Okay, this is one scenario which I have covered wherein the after session expiry timer, this 603 has got declined. Okay, and if this phone remains, this phone was uh, uh, phone got unregistered because phone has a timer of in address record for 60 seconds. That's what we saw in just in the previous slide. The phone is there in the record for 60 seconds. In 53 seconds, if it is not rebinded, then it will be considered as unregistered. So what is happening here is, instead of waiting for the 60-second expiry, n- uh, we are trying to make a, this phone gives a response. This timer is getting expired because our call connection time limit is only 30 seconds. So within 30 seconds, it identifies that, okay, call is not getting connected. So it will send out a 603 decline. On a contrast, there is a simple another scenario wherein we are sending after a phone. Here is there is a different scenario here. We are trying to make a call to a phone which got disconnected. After session expiry, it got unregistered. So after this 60-second second has completed, exhausted, then Ashley said, okay, fine, till 60 seconds, I did not see a rebinding request. Let me unregister this. After unregistration, if I'm calling to this phone, we'll see 404 not found. As you can see here in this Wireshark address, you can see 404 not found. Okay. And then there are a few scenarios of proxy, but mainly I wanted to cover up was this Wireshark addresses through live capture. So Shankar, do let me know if you want to go and discuss something more, want to capture some more traces, we can do that. Uh, Shankar, or is anybody there?
Yes, Binod.
Yeah, Shankar. So I could cover some of those things in live demo, but for
Mm-hmm.
some I had to, run through the slides, whatever I had captured actually. So do let me know if, anything we want to talk about in detail again, or you want to do a demo. Uh, I'm ready to do that now. Any scenarios which we want to recreate, except this proxy. Uh, but if you want
The
to recreate any of the scenario, I can do that now, or any queries related to it.
I think I am pretty much good about whatever you covered. Binod. It's up to the audience if they have any specific scenarios that they would like to understand, then they can come up with a scenario.
So we'll give some time duration and wait
Great.
for anybody to put question.
Yeah, with this we're completing the session, right?
Yes, I intend to complete this.
Very good. I think it's more than what we can get it in the certified training courses as well, So even they will not cover in detail as you covered. Wonderful,
Yeah.
actually. So I mean, I myself have good understanding about SIP, but you covered the way beyond that level actually. So exceptional, I would say.
Oh, no, thank you,
Those
sir.
who
But
have who utilized this session, no, they will really uh, uh, feel worth actually. So wonderful session though.
actually, want to take an advantage of talking about, if anybody is listening, I want to talk about this 401 because it was always coming up on the way. Uh, if that is okay to continue because recording is still on.
I
Okay.
just stopped
Okay, no worries.
it.
Right.
uh,
Okay, so I welcome any question, any doubt. I'll try to answer them in case if you'll have through all this session. And I pass it over to Shankar to you. How do you want to continue? If you want to close the call, we can.
All right, guys. Thank you so much for participating in this session. I hope you guys would have picked most of his most of his brain and scenarios that he covered. They are all. Uh, uh, I mean, you can't even study those information in the internet actually. So they're all live sessions that he covered. So wonderful, wonderful hands-on experience that he has had. So kudos and thank you so much, Binod. Wonderful. Please go through the recordings if you guys have any questions or any doubts related to the topics that he has covered. Okay, so that will help you. And if anyone else would like to cover any of the topics that you guys are strong in, okay, so any of your favorite topics that you guys wanted to cover as part of this tech talk session, which happens once in 2 weeks, right? So next session will be on 19th July. So if anybody would like to volunteer for any of your area of experts, no, just reach out to me. I'm more than happy to schedule the session for you guys.
Okay. Thank you, buddy. Thank you, everybody. Have a nice weekend.
Thanks, everyone. Thank you so much. Have a e- nice weekend, nice evening, rest of the day. Thank you.
Thank you, Binod.
Yeah, thank you.
Thank you, guys.
Thank
Yeah.
you. Thank
Thank you.
thank you, Vinod and Shankar.
Thank you, guys.